Somewhere past the edge of the sun's influence, more than 21 billion kilometers from here, a spacecraft older than almost everyone listening is losing about 2 watts of power a year and quietly refusing to go dark.
And this week, a team of engineers found a way to give it another year of science. Good morning or good evening wherever you are. This is Astronomy Daily. I'm Avery.
And I'm Anna. It's Wednesday, the 5th of August. Today, a clever rescue for Voyager 2, a cell tower that fits in a rocket fairing, a sea of honeycombs on Mars, and a little telescope about to go hunting for the universe's missing gas. Plus, everything worth looking up for, north and south.
Let's get into it.
Let's start out at the very frontier of everything we've ever built. Voyager 2 launched in 1977. That's nearly 49 years ago. And it's still, right now, sending back data from interstellar space. It crossed the heliopause, the boundary of the sun's bubble, back in November 2018. It is over 13 billion miles from Earth. That's about 21 billion kilometers.
And when you're that far out, a conversation takes a while. A radio command from Earth needs the better part of a day just to reach it.
Close to 19 or 20 hours one way, so you can't exactly troubleshoot in real time. Now, here's the challenge the mission has been living with. The Voyagers don't run on solar panels. Out there, sunlight is basically useless. They run on what's called a radioisotope thermoelectric generator, an RTG, which turns the heat from slowly decaying plutonium into electricity.
And the catch with decay is that it never stops. Every year, both Voyagers lose about 4 watts of power. 4 watts doesn't sound like much. It's a fraction of an old light bulb. But do that for almost half a century, and the margins get razor thin.
So thin that since 2024, the team has had to switch off 2 science instruments on each spacecraft just to keep the lights on. And they were staring down another one. Without intervention, Voyager 2 would have had to lose yet another instrument before the end of this year.
Which is where this week's news comes in. And I love that they gave it a nickname. NASA's Jet Propulsion Laboratory calls it the Big Bang.
It does sound dramatic for what is essentially very careful housekeeping. The Big Bang was a coordinated move. The engineers simultaneously turned off certain powered devices on the spacecraft and swapped in lower power alternatives, all while making sure Voyager 2 stayed warm enough to keep functioning, because out there, the cold is another enemy entirely. Let a propellant line freeze, and you can lose the whole spacecraft.
And the payoff for all that care?
They freed up enough power to keep 3 science instruments running for at least an extra year. An instrument that was going to go silent in 2026 now stays on. And the team says they'll try the very same trick on Voyager 1, which is even further away, in the coming months.
So what are those 3 instruments actually doing out there? Because Voyager isn't taking pretty pictures anymore. The cameras were switched off decades ago.
Right. What's left are the fields and particle senses. On Voyager 2, that's the magnetometer, which feels the magnetic field, the plasma wave subsystem, which effectively listens to the density of the charged gas around it, and the cosmic ray subsystem, which counts the high-energy particles streaming in from the galaxy. Together, they turn interstellar space from a line on a diagram into an actual measured place, the only direct readings humanity has ever taken from outside the sun's bubble.
And here's a detail I think our Australian listeners in particular will love. When JPL wants to send the command to Voyager 2, there's really only one antenna on Earth that can do it.
Canberra. Voyager 2 headed south out of the solar system, below the plane of the planets, and from that angle, the only dish with a clear line to it is the big 70-meter antenna at the Canberra Deep Space Communication Complex. So every one of these life-extending commands, the Big Bang included, goes up through the southern hemisphere. There's something rather lovely about that. The oldest working emissary we have stays in touch through a dish in the New South Wales bush.
And the people behind it are a story in themselves. The mission has NASA retirees in their 80s advising on subsystems they helped design in the 70s, working alongside team members so young their parents hadn't been born when Voyager launched.
2 generations, 1 spacecraft, and a running argument with entropy that they keep somehow winning by a year at a time. The honest truth is the Voyagers are in their twilight. Every watt now is a decision about what humanity still gets to learn from out there. But this week, the twilight got a little longer, and that's worth marking.
The little spacecraft that could, still could. Next, from the oldest hardware in the sky to some of the newest. In the early hours this morning U.S. time, a SpaceX Falcon 9 lifted off from Cape Canaveral and delivered 3 new satellites, Bluebird 11, 12, and 13 into orbit for a company called AST Space Mobile. And true to form, the first stage came back for its 30th successful landing.
And the pitch behind these is genuinely futuristic. No special phone, no dish, no satellite handset. Your ordinary, unmodified smartphone connects straight to the satellite.
Straight up to orbit. The trick is scale. To reach a normal phone, which has a tiny antenna and not much power, the satellite has to do the heavy lifting with an enormous antenna of its own. These next-generation Bluebirds unfold phased array antennas of around 2,500 square feet. That's the largest commercial array ever flown in low Earth orbit, roughly the footprint of a decent-sized house up there in space.
And they're faster than the first batch.
Nearly double the peak download speed of the earlier Bluebirds, which had already hit close to 100 megabits per second straight to a standard phone. This trio follows 3 that went up in June, and the company is aiming to start beta service later this year, building towards a constellation that can give proper coverage across its key markets.
It's worth being clear-eyed about it. They're not the only ones chasing direct-to-phone from space. SpaceX's own Starlink is doing a version of this too. But the promise is the same, and it's a big one.
The idea that the dead zone, the bottom of a valley, the middle of the outback, a boat well offshore, just quietly disappears. For the billions of people still unconnected or underconnected, that's not a gadget story. That's infrastructure.
Now to Mars, and a bit of an anniversary, because today, the 5th of August, is 14 years to the day since NASA's Curiosity rover touched down in Gale Crater. And it has marked the occasion, more or less, by finding something that stopped the mission team in their tracks.
This is the honeycomb terrain everyone's been sharing.
It is. As Curiosity climbs a valley the team has nicknamed Valley Grande on the slopes of Mount Sharp, it rolled into a landscape covered with polygons, honeycomb-shaped cracks in the ground, each one only about 4 to 8 centimeters across. The rover has seen little patches of these before, but never anything on this scale. In a 360-degree panorama stitched from over 300 images, the shapes spread out in every direction, as far as the camera can see. They even wrap around the base of a small butte.
The project scientists put it beautifully, said that after everything they've seen through Curiosity's eyes, this sea of polygons still took their breath away. So what makes a honeycomb like that?
Water, or the memory of it. Patterns like these can form when mud dries and cracks, or through repeated cycles of wetting and drying, or when buried sediment gets squeezed and pushes water out. And that fits the bigger picture of where Curiosity is. The foothills of Mount Sharp are thought to have hosted lakes and streams billions of years ago. So this isn't just a pretty texture. It's another line of evidence for a Mars that was once wet, layered into the rock.
14 years, wheels worn down to holes, and it's still turning up genuine surprises?
Still climbing, still reading the story written in the stone. Not bad for a mission that was only ever promised 2 years.
Our last story today is a look ahead to a launch just 10 days away, and one with a distinctly southern hemisphere flavor. Around the 15th of August, a Rocket Lab Electron is due to lift off from Mahia in New Zealand, carrying a NASA mission called Aspera.
And Aspera is tiny. This is not a flagship observatory.
It's roughly shoebox-sized, a small satellite, part of NASA's Pioneers program, which funds genuinely ambitious science on a modest budget. But the question it's chasing is enormous. Aspera will be the first NASA mission to map in ultraviolet light the hot, diffuse gas that drifts in and around galaxies, what astronomers call the circumgalactic medium.
And this ties into one of the quiet embarrassments of cosmology, doesn't it? The missing baryons.
It really does. The mission's principal investigator put it almost sheepishly. We have a good idea of how much ordinary matter there should be to explain all the stars we see. And yet, we've searched far and wide and still can't find most of it. A lot of it is thought to be hiding in this faint gas between and around galaxies, too diffuse to see easily. Aspera is built to trace it, the gas flowing in to build new stars and the gas being blown back out.
And there's a nice human footnote.
There is. The mission is led out of the University of Arizona by one of the youngest principal investigators in NASA's history. A small telescope, a young scientist, a big question launching from a cliff top in New Zealand. We'll be watching for it around the 15th.
And that brings us to the sky. Tonight first, then a big fortnight ahead. And I'll be straight with you about who gets the best of it. Tonight, the moon is at last quarter, so the first half of the night stays nice and dark before it rises. And in the pre-dawn sky, Mars is sitting in a neat little triangle with Elnath, the bright star that marks the tip of Taurus's horn, and the star cluster M35 over in Gemini. Mars and Elnath are easy naked eye. Grab binoculars for M35, and you'll find that soft glow of stars just beside them. That one's there for everybody, north and south.
And then there's the 12th of August, which is shaping up to be the single biggest sky day of the year.
3 headline events in 24 hours. So let's take them honestly, one at a time. First, a total solar eclipse. This one traces a very unusual path. It touches down in the Arctic near eastern Siberia, nearly grazes the North Pole, then sweeps over Greenland, Iceland, where totality peaks at a little over 2 minutes, and finishes over northern Spain around sunset. It's the first total solar eclipse to reach mainland Europe since 1999. Parts of the United States, from Alaska across to the Northeast, get a partial bite out of the sun.
And for our Southern Hemisphere listeners, including me, the plain truth is we don't see this one at all. It's entirely a Northern Hemisphere event.
We don't, but NASA and others will live stream it, so you can still share the moment. And one rule that never gets trimmed on this show, if you are anywhere the sun is even partially eclipsed, you need certified eclipse glasses that meet the ISO 12312-2 standard for every partial phase. Ordinary sunglasses will not protect your eyes, and never point a camera, telescope, or binoculars at the sun while wearing eclipse glasses. The concentrated light can destroy the filter and your sight in an instant.
Second event, that same day, the Perseids.
And 2026 is a special year for them because the peak on the night of the 12th into the 13th falls on a new moon. No moonlight at all to wash them out. The next time that lines up is 2045. From a dark rural site, you might see 30 to 50 an hour and up to 100 under really pristine skies. Now, the Perseids favor the northern hemisphere. The point they radiate from climbs high in the north and barely clears the horizon down south. So, northern listeners, this is your night. Southern listeners, you'll catch far fewer, but a patient hour after midnight looking northeast can still turn up a few bright ones.
And third, the planet parade.
6 planets strong along the pre-dawn sky around the 12th. Mercury, Venus's neighbor Jupiter, Mars, Saturn, and the 2 ice giants Uranus and Neptune. Don't picture a tidy line. It's a broad arc following the ecliptic. Mars and Saturn are the easy naked eye ones. Uranus and Neptune need binoculars or a telescope. Mercury and Jupiter sit low in the dawn glow. For North America and the northern mid-latitudes, look about 30 to 60 minutes before your local sunrise, with the arc running towards the southwest. Down south, the window's a bit later and shorter, and the arc leans towards the northwest, and the mornings either side of the 12th work just as well, so treat them as practice runs.
So the 12th leans north. What does the southern hemisphere get to call its own?
Plenty, actually. On the 7th, a modest shower called the Eta Eridannids peaks, only a few an hour, but it genuinely favors southern observers. The winter Milky Way is riding high for us, so the Sagittarius starfields, the Lagoon Nebula, and company are beautifully placed under a dark sky. And mark the calendar for the 27th into the 28th, a deep partial lunar eclipse that's visible across much of the Americas and parts of Europe and Africa, a proper both hemispheres event to close the month. We'll have full local timings closer to each one.
That's your lot for today. Voyager's second wind, a phone tower in orbit, honeycombs on Mars, and the little gas hunter warming up in New Zealand.
You'll find all our sources and links in the show notes and over at astronomydaily.io. And you can find us on all your usual platforms at @AstroDailyPod. And keep an eye out tomorrow. There may just be word on whether that derelict rocket stage left a fresh mark on the moon.
Until then, from Avery
And Anna.
Clear skies.